Hi guys. So this is for module 6 through 7, forms of linear equations and inequalities. So let's get going with talking about slope-intercept form. So we're going to do this with context. So we do get started with the situation. All right. Pretend you are Andrew here. Okay. Andrew wants to buy a smartphone. It costs 500 bucks. Okay. Now his parents will pay for the phone, and Andrew's going to pay them 50 bucks every month. Okay, until the amount is repaid. Now in slope intercept form, you can do y equals. Thank you, touchscreen. Y equals -50 because he's going down 50 bucks every month in the amount that he owes, and months is represented as X. Okay, or as in payments. Okay, and y is the amount of money he owes. Now he starts off owing 500 bucks. That's the initial value. All right. So again, the initial value for number one is 500 bucks. That's how much Andrew starts off owing them. Now, if I was to plot this on the graph, it'd be at 0, 500. Okay, that's how much money he owes. Now, if you think about rate of change on a graph after the first month, okay, we're going to actually see a table later on, but after the first month, okay, -50 times 1 is -50. -50 plus 500 is really just 450. So after the first month, he's down here at 1 or 450. All right, so that's something to note. Okay, so will there ever be a situation where the y-intercept and initial value are not interchangeable, meaning that they're not always going to be the same thing? Yes. In this situation, your y-intercept is 0, 50. All right, or I'm sorry, 500, 0, 500. Now, are there times where, for example, Andrew isn't going to have 0, 500? It's possible. What if his parents said, "Oh, Andrew, you're going to start owing us 500 the next month." Okay, so technically, his first month, when n equals 1 month, his f of n is still going to be 500. Now, you see this a lot with sequences. So sequences commonly see this. And the quickest example that I can give you, the easiest example, is n of a function for the value of n, and your first term is, let's say, 3, your second term is 6, your third term is 9, but do you notice how you don't have a 0, comma b? Okay, you don't have a y-intercept. You do have an initial value of 3, but that's not your y-intercept. Okay, so there's times when your initial value and your y-intercept are not the same thing. So be careful with that impression that you're always talking about your y-intercept, because we might not. Depends on the situation. All right, so thinking space. So we're going to fill out this chart, determine how long it will take Andrew to repay the loan. We're going to determine the input and outputs and write the function to model the situation. So if you look here, in 0 months, Andrew owes 500 bucks. Okay. And then, so first month or 0 months, right? And 0 months at the very beginning, he's not paying them, right? The parents are basically just like, Andrew, you owe us. And he's like, okay, but he doesn't give him 50 bucks right there. He just knows, so well, when next month I have to pay 50 bucks. So he still owes them 500 bucks. Now the first month rolls through, he still owes 500 bucks, but he gives his parents, Andrew gives his parents a $50 bill. So now he only owes them 450. Second month comes through. He still originally owed him 500 bucks, but now he's paid them two $50 bills, which makes him down to $400. So if you can see here, our rate of change is down 50 bucks for every month. Okay, so every 1 month. Now you could always follow the pattern, okay, because this is a linear equation or a linear relationship. So it should still just keeping that pattern of minus 50 bucks, all right, all the way down. Now, some of you guys actually did something like this on your test. You weren't able to figure out the equation, but you knew that you kept on having this pattern, okay, and you were able to do it all the way through like 10 months or something like that. All right, so third month, fourth month, fifth month, He's still paying off $500, but this time he's already handed them three $50. Okay, so 500 minus 150 is 350. He still starts off in the fourth month. He still originally owed them 500, but he's already paid them four $50 bills. Okay, and you guys get the idea, right? Just 5 months. He originally still owed them for $500, but now he's paid them five $50 bills, which is 250, and 500 minus 250 is 250. Okay, now the pattern that you're seeing is f of x, in this case y, right, equals minus 50x plus the original that he owed. Okay, so again, this was your rate of change minus $500 or $50 every month plus what he already owed his parents, the 500. All right, so if we were to graph this, by the way, off the table, which is something to do, we're going down 50 bucks, 50 bucks, 50 bucks. That's our rate of change. 50 bucks, 50 bucks, and then lastly, bam. Now, in real life, this is discrete, but I want you to go ahead and draw a line anyways. Okay, that's a terrible line. I totally understand. Believe me, on a touch screen, this device I'm using isn't always nice. All right, but there we go. Okay, the reason we could do this is because what if Andrew decides to pay like an installment in the middle of a month? Okay, then how much in the middle of the month would that be? All right, so in the middle of the month, what if he was paying them? That'd probably in the middle of the month that'd be an extra 25 bucks. All right, so that's why we'd use a line in the situation, just in case Andrew wanted to start paying them earlier or in smaller increments. It's really up to Andrew. All right, so analyzing the linear function in context. What is the rate of change? Again, it's minus $50 every month. Okay, he's paying off 50 bucks every month. How do you determine it? Well, we also looked at the table, okay, and also the verbal description, which we did in Module 5. Okay, he's paying them 50 bucks, so that's minus 50 bucks every month. All right, what is the interpretation of the rate above according to the story? The rate of change. It's basically the same. It's just minus 50. Okay, minus $50 every month. All right, so the interpretation is that he's paying his parents monthly. All right, now how can you show that on a graph? And I graphed it above already. Okay, if you looked up here, again, 1 month goes by, Andrew pays 50 bucks, so he's down 50 bucks. 1 month goes by, he pays another 50 bucks. So this is still rise over run. It's just you're going down 50 and running 1 month. Okay, so it's still along with the idea of slope, but now we're just talking about rate of change because it's context. All right, so graph that, awesome. Now using the verbal description given, write the equation in slope-intercept form. So again, this was a part of what was already given with Andrew, so minus 50 bucks, and you already owed 500. Okay, now just please note you're in algebra now, and we use function notation. That's always nice. Okay, especially when we start comparing different functions, which we do start to do. Standard form. Now, if I was to rewrite this in standard form, now originally we had what? Y equals negative 50x plus 500. But standard form says, well, the x term and the y term have to be on the left-hand side. So how do you get rid of a minus 50x? A plus 50x. And remember what you do to one side. This is the property of equality for addition. So we're going to have 50x plus the y equals 500. Okay, that would be a great example of standard form. Now, discuss and compare the following equations. So you guys have seen this. What is that called? Slope equation, yeah? Well, in Algebra 2 especially, when you get a little older, you're going to come across this equation, okay? And delta is that triangle here and triangle here. That means change. So when you read this, this is change of the function for the value of x. and this is the change in x. Basically, it's the same as change in my y over the change of x, okay? And you have seen that before in Math 8, change in y over change of x. So what does this mean over here? Well, we have f of 10. Now, what does f of 10 mean? F of 10 means, and if you look here at our table, f of 10, well, where was the dot, where was the ordered pair when we were at 10 months, all right, for Andrew? Oh, it's at 10, comma 0. Okay, so this means basically we have our x and we have our f of x value. So when x was 10, what was our f of x value? 0. So f of 10 equaled 0. Okay, now what was our value for the f of 0? Let's go at the table again. For when x was 0, f of x was 500. So let's go minus 500. Oops. Minus 500. That's how much he owed. Okay. Now we had 10 minus 0 because this was from 10 months to 0 months. We have negative 500 divided by 10. You reduce, and you should get negative 50. Thank you, touchscreen, for doing whatever you just did. There we go. Minus 50. Well, wasn't that our rate of change? Okay, so our change in f of x, again, that's a triangle, terrible triangle, divided by our change in x equals negative 50. All right, so notice how this equation is very similar, if not exactly the same, because it is, to the slope equation. You can always double check it. All right, so double check it if you want, and you should get still negative 50. All right, so in context, what would the domain and range be for Andrew's situation? Now for domain, Andrew dealt with 10 months. If you look at the graph, remember domain means x, so that's something to note. We went from 0 months to 10 months. Okay, so that's something to note. So we were greater than or equal to 0 months, or less than and equal or equal to 10. Okay, now our range, again, our range is y values, right? We owed originally $500, so less than or equal to 500, or greater than or equal to $0. Okay, so domain would be the months or the time, and range is the money. All right, so let's look at homework section. So slope-intercept form. So rewrite each standard form into slope-intercept form. So I'll get you started. We want this in slope-intercept form, so let's get rid of this plus 2x. What we do to one side, we do to the other. And you should get y equals negative 2x plus 4. What's my b? What's my initial value? Okay. In this case, it's my y-intercept because it's a line, okay, not a sequence. And our rate of change, or our slope, for our graph is going to be down to 1, 2 over 1, because our slope is negative 2. Our rate of change is negative 2. Follow the pattern, and you should see where your line should be drawn. Obviously not there. That's a touchscreen. What is going on with my touchscreen today? There we go. All right, so that's how you do it. So again, do part B, do all of it. Do all of it. Number 2, there we go. So number 2, chairlift descends. I think yours is, it made it safely onto the other paper, okay? So just notice that that part is meant for the part down here. It's talking about a chairlift, okay? So notice, for example, they already give you the graph. You start here, They give you a coordinate here, which you could totally use for this part, okay? They're asking you for part A, what's the initial height, just like with Andrew's situation. Um, they're asking you for the rate of change, which is from part B, okay? So that's something to acknowledge. And then they're asking you for slope-intercept form and standard form, okay? Again, slope-intercept, y equals mx plus b. Thank you, touchscreen. And standard form, again, is basically something times x, could be 1, plus something times y, could be 1, equals the amount that you start off at. All right, so again, they're asking you about domain and range. Then they ask you about, is this a solution to the chairlift relationship? So what you need to do is go to 2 comma 3900 and see if it actually lines up on the line over here. So again, you're going to look at 2, and then you're going to go up and you're going to see if it stops right there at 3900. All right, so does it? Okay, and then explain why. Use slope-intercept form to verify. So not just the graph, why don't you check it? All right, so find your rate of change, find your equation up here, use that part to solve for that question. You should get a solution. Remember, it's a true statement. All right, so for number 3, identify your y-intercept. So we've done this before, tables. Okay, where am I starting off? And then what's my rate of change as we go through here? Okay, so find your rate of change. What's my change in money? What's my change per month? And reduce. You can actually reduce here. Okay. All right. So starting off the next section, point slope form. All right. So like the name suggests, the point slope, and again, I think your copy has this one written down on this page. Okay. Don't know why, but when I open these documents, everything's shifted up. I don't know why it does that. All right. So point slope form, like the name suggests, the point slope form only relies on a single point and rate of change. All right. That's why they call it point slope, because you only have a point and you get the slope. Now, this form derives from the following formula. So here's our slope formula that we've seen before. And then basically all that happens is they use the multiplication property to both sides, and they get the x's on the left-hand side. And I went ahead and used the symmetric property to get this. Now, this is point slope form, okay? Now, it's very useful when you're trying to determine the following situation here. So Paul wants to place a ad in the newspaper. The newspaper charges $10 for the first 2 lines, okay, of a text, and 3 for an additional line of text. Paul's ad is 8 lines long. Oh, okay. How much will the ad cost? So in this situation, we have 2 lines costing $10. That's a point. Okay, that's a point in our situation. Now the rate of change is $3 per line. Okay, so that's our slope. Awesome. So we have our x value, we have our y value, and we're just going to plug it into our equation. So our y value was 10, so it's minus 10. Our slope was $3, okay, per line, and our x value was the 2, so minus 2. All right. I'm going to go ahead and eventually oops, not do that. Come on, there we go. Okay, so you're going to go ahead and 8 minus 2 is 6, and 3 times 6 is 18. We still have that minus 10 there, so I'm going to add 10 to both sides if my little touch pen will let me. Technology for the win. All right, plus 10, there we go. And you're going to get y equals 28. So 8 lines is going to cost you 28 bucks. So this is how we use point slope to determine a certain other point in our relationship, in our situation. So go ahead. Number 2 is going to be homework. That's for you. Same situation as earlier, okay? So what's your slope? And then what's your coordinate? Okay? What's my x? What's my y? It's very identical to the first one. So figure out what's your x, figure out what's your y, and then just substitute. You can use the fill in the blank. Okay, guys, I think that's it for the video. if you have any questions, let me know. This is again is just for part one about point slope form and the slope intercept form part. If you guys have any questions, I'll be back on Thursday. And yeah, have a great day.